Relativistic quantum mechanics actually is not very useful for anything. The actual technology we developed doesn't depend on that. It doesn't appear to be very useful. But a lot of these, Maxwell's really useful, ordinary quantum mechanics is really useful, quantum dynamics is really useful. The others here, the standard model that goes beyond these, because the standard model contains those, at the moment there are no technological applications for those things that are known about. You use the simpler theories to actually make stuff that does stuff.
Why?
Because that's what works. You use what works. So if I'm imagining, when I was imagining this single electron stuff, I'm thinking in quantum mechanics. How does that work? In order to visualize what you need to do, in order to model the thing and then have it made, because I didn't make it, but I had it made by part of my team then, our team. Then you make it and it does stuff. You're not just making something random, you're thinking what you have to do through that language which allows you to, well, to think about it. It gives you the mental tools to be able to think about what you need to do. That's how things progress. Not always. I mean, the other way to do it is copy it from somebody else and then do exactly what they do, which is quite rife, but steal it in other words. But if you want to do something new, then that's what you do. You imagine it, and then you make it, and then it does something.
So when did you first imagine this?
1991.
And how much has that shape changed?
Not at all. We got it exactly right the first time. It's a very simple shape, though. You know, it's a paradigm shape. It's a double loop. One twist, periodic boundary conditions, biting its own tail. So, but the thing is that what you get, and what Martin also did, is, look, you can have that shape, but actually you don't just have that shape, you have all possible shapes. You also have this one. And as I'm moving that, I'm making, you've got to imagine just between here and here, I'm putting a thicker and thicker donut. I'm making this thing thicker and thicker. And what that does for you is it makes the outer loop get bigger and the inner one get smaller. So it's like a bunch, imagine a bunch of nested bagels, one inside another, made with flaky pastry or something, right? So you've got a thin one in the middle, which is just a ring, and then outside that they get thicker and thicker and thicker, and around each one of these is going a twist which goes round once as it goes round that donut. That's the quantum bicycle motion.